Hi, my name is Claudiana bin Azhari. My number metric is 208050. So today we're going to learn about the fundamental principles of first and second. These sessions, we're going to cover two subtopics, which are first law of thermodynamics and second law of thermodynamics. So the first law of thermodynamics, often called as law of conservations of energy. The definitions for this first law of thermodynamics is heat is a form of energy, and as well, all other forms of energy is subject. It follows the law of conservation of energy. So, as we all know, energy is conserved, which means that the amount of energy before will always be the same as the amount of energy after. Um, this law of conservation of energy state that the heat energy also cannot be created or destroyed and transferred one to another. So this is basically about heat as energy and the law of conservation of energy. To understand more about first law, let's take a look at example that we can relate it to our daily life. Example is a stone that contains energy. Coal can transform heat energy by undergoing heat combustion. This is because, as I said, clean energy that can produce heat energy. Some company use to utilize it to generate electrical energy, what we know as electricity. So how does this process take place and the electricity take place is first, coal will be fed into a boiler furnace with the little heat creates combustion in the form of energy. Then the heat energy will transfer to water above it, making it into the system. Next, the steam will rotate the turbine, which will undergo a mechanical energy. This turbine will detect a generator which convert the energy into electrical energy. Other example that we use is light. By turning a light, produce energy. This is electrical energy that is converted. Um, a way to express the first law of thermodynamics is that any change in total energy of a system is given by the sum of the heat that flows across its boundary and work done on the system by the surrounding. So this is the equations to find the net change in the energy. This law says that there are two kind of process which are heat and work. These two can lead to a change in the net energy of system. Like I said earlier, if heat flows into a system surrounding the works on it, the internal energy will increase. Therefore, the sign of heat and work will be positive. If heat flows out of the system, work done by the system surrounding be at the expense of the internal energy, then the sign of heat and work negative. Next is the second law of thermodynamics. So the definitions for the second law of thermodynamics principle stating that every energy transformations increases the entropy of the universe. Other forms of energy are at least partly converted heat. Explain this. The explanation for these definitions is heat cannot be accessed by water. The second law of thermodynamics says that the entropy of any isolated system always increases. Isolated systems spontaneously evolve where thermal, which is the state of maximum entropy of the system. More simply, put, the entropy of the universe, the isolated system, only increases and never increases. There are the major statements of the second law of thermodynamics are following. The first one is Clausius state. It is impossible for any system in such a way that the sole result in energy transfer by heat the water body. Next statement, Kevin Planck statement. It is impossible for any system to break thermodynamic cycle and deliver net energy by work. surrounding by receiving energy by heat transfer a single server. Lastly is entropy statement, which is the third one. It is impossible for any system operates in a way that entropy is destroyed. There are two easier ways to make it easier to understand this law. So the first is high entropy. For any process, a natural flow will always be high energy. For example, we use coffee as example. So the temperature of coffee is higher than the cup of um, therefore the temperature of coffee will get transferred to the cup, which is cooler and have a lower energy value. That is why the cup gets hot when you touch it. Next is perfect is impossible. For every real process, there will always be losses. For example, you cannot convert all of your coffee. For example, as a cup, you cannot convert all of your coffee to energy state God's will. Proof this we use as example. When we try bouncing the ball by throwing it up the air, you can see that the level of bounce decreases because of the loss of energy which is transferred to Okay, this is simple an example for us to understand what is the same dynamite. Put an ice cube into a cup with water at room temperature. Water of heats to melt the ice cube. As a result, the entropy of the water, the ice cube absorbs the same amount, therefore its entropy increases. I think that's all for me.